So next chapter is thermodynamics. It is also important chapter for MHTCET. So first we understand what we cover basic concept, heat and work, first law, process, isothermal, adiabatic, etc. PV graph, heat engine and refrigerator. So first we understand what thermodynamics is. Thermodynamics deals with the heat. Thermodynamics. It's deal with the heat, work, energy. It studies how energy transfer and transform. Now very important term, system. System means the part of universe which we are studying, and surrounding means everything except the system. Boundary, the real or imaginary surface separating system and surrounding. Now the type of system. There are three types of system: isolated, closed, third open. So isolated isolated system. No heat, no work, no matter exchange. In isolated system, no heat, no work, no matter exchange. In closed system, heat, work, exchange allowed, but no matter. In open system, heat, work and matter all can change, all can exchange. Now heat versus temperature. Heat. Energy is in transit due to temperature difference. Heat SI unit is joule. Temperature is a measure of the average kinetic energy of molecules. SI unit Kelvin. Remember, heat flows from high temperature to low temperature. Now, sign convention. This is very important for numericals. Heat added to system is taken as a positive. Heat released by the system is negative. Work done by the system is positive and work done on is negative. If you make mistake here, whole answer come out. So important. Next, work done in thermodynamics process. Work done in thermodynamic process is W is equal to integrate P dV. Graphically, work equals the area under P curve. In isochloric, the work in isochloric, sorry, 0. No volume change. V equals to constant. Isobaric P V2 minus V1. The graph area under PV graph. If volume does not change, like in a isothermal process, then work done is 0. If pressure is a constant, the isobaric process work equals to P V2 minus V1. Okay. So the graph under V curve has to work. Next, first law of thermodynamics is very important for delta U equals to Q minus W. Delta U is a change in internal energy and Q equals to heat absorbed. W is a work done by the system. By system is positive. In isothermal process, temperature constant, delta U equals to 0. So Q equals to work done. In adiabatic process, Q equals to 0, then delta U equals to minus work done. This is the law of conservation of energy. Change in internal energy is equal to the heat supply minus work done. Okay. In isothermal process for ideal gases, temperature constant. So equal to 0. Therefore, Q is equals to W. In adiabatic process, no heat exchange. No heat exchange. Q is equal to 0 and delta U equals to minus W. Next, internal energy. Internal energy depend on the temperature. For ideal gas, internal energy depend on the only on the temperature. Formula: U 3/2 and RT for monoatomic. General U equal to A/2 T. Mechanical equivalent to heat. 1 calorie equals to 4.186 joules. 4.186 joules. Next, reversible versus irreversible. Now, reversible. Reversible process happen infinitely slowly. No friction gives maximum work. Irreversible happen at a real speed. Friction present. Work is less than maximum. In exam, reversible always give more work. Reversible always give more works. Speed infinitely slow. Real speed. Friction non reversible present. Working reversible maximum. Irreversible less than maximum. Next topic is intensive versus extensive. Intensive is independent of mass. It do not depend on mass. Just like example, temperature, pressure, density. They are not depend on do not depend on mass. They are called intensive properties. And extensive properties depend on the mass. Example, volume, internal energy, mass. Is also important. Next topic is thermodynamics process equations. First, isothermal. Temperature constant, PV equals to constant, the work done equals to N or T ln V2 by V1 or T ln P1 P2. Next, adiabatic, no heat exchange, Q equals to 0, PV to the power R is constant, gamma to the power of V, T equals T into V, the power gamma minus 1 equals to constant, where gamma equals to Cp by Cv. Work equals to P1 V1 minus P2 V2 divided by gamma minus 1. So next process is isobaric. Pressure equals to constant, so work done equals to P V2 minus V1. Simple. Isochoric, volume constant, work done equal to 0, delta U equals to Q. Simple. Next, cyclic process. Return to initial state, delta U equals to 0. Now, PV diagram graphs. Isothermal curve PV equals to constant. Isothermal curve PV equals constant. Adiabatic, this steeper curve than isothermal. This is a adiabatic. Isobaric horizontal. Volume constant. This is isochoric process. Volume constant. Next, coefficient of performance COP. For a refrigerator, COP is a QL by W. For a heat pump, COP HP equals to QH divided by W. The higher COP, better cooling. And COP is always greater than 1 for refrigerator. An entry for MSL. Check sign convention carefully. If T equals to constant, delta U equals to 0. Work is always under the PV curve. For adiabatic process, no heat step curve, and COP is greater than always for refrigerator. COP is greater than 1. The coefficient of performance for refrigerator is always greater than 1. So thank you for watching. Subscribe, share, like. Thank you.